So first, let's review what FOIL is. The acronym FOIL stands for first, outer, inner, last. And the color coding here will help you see what terms in this binomial should be multiplied. So the red is F. F stands for first. So I'm going to multiply x times x, which gives me x squared. The O, the orange, stands for outer. So I'm going to multiply the two outer terms in my parentheses, and that's x and positive 2. Well, x times 2 gives me 2x. I stands for inner, the purple. 1 times x is going to give me 1x. Now, I don't have to write that 1, but I'm going to because it's going to be a placeholder and remind me when I'm combining like terms that I should include that 1. L, the green, is for last. 1 times 2 is 2. And now I need to combine like terms. I only have one of these x squareds, so I can't combine it with anything else. Here I have 2x and 1x, and when I combine those together, I get 3x. Then my constant, my 2, is all by itself. I don't have any other constants I can combine it with, and so I have just plain old 2. And this is my multiplied out answer. Now when we factor, we're going to go backwards. We're going to start with something like this and end up with something like this. So let's start with this fairly simple, straightforward problem, and I'm going to show you how to use the Xbox method of factoring. So when we do Xbox, we draw an X in a box, and what we are going to fill in first is our X. Now remember, this is a placeholder of 1. It's understood to be a 1. In the top part of my X up here, I'm going to multiply A times C. A is 1, C is 2. Got A, B, and C. So 1 times 2 gives me 2. And my inner term, my 3, or my B, is going to go in the bottom. Now, what I'm looking for to go here and here are terms that multiply to equal 2 and add to equal 3. Well, the only two numbers that happens with are positive 2 and positive 1. When I multiply them, they equal 2. When I add them, they equal 3. Now I'm going to take my numbers from my X and I'm going to fill in my box over here. So I'm going to take my 2 and my 1 and I'm going to put them here and here. It does not matter if I had these switched. You'll get the same answer at the end of the problem. What you do have to remember to include is your X, or whatever variable was right here with your B term. So it's like you're taking this B term right here and you're splitting it up into these two. But first we have to go through the X before we can go straight to the box. And now I'm going to put my A term here and my C term here. Notice I included all of my positive and negative signs here. That's going to be important when you're deciding what signs go in your greatest common factor. Next, I'm going to find the GCF of each column and each row. So first I'm going to start right here. My greatest common factor for x squared and x is just x. I'm looking for the largest number or variable that goes into both of my terms. Here, the largest number or variable or both is going to be positive 2. Now I know that this is a positive 2 because this is a positive. The sign here will match the sign right next to it. That's important to keep in mind. Next, I'm going to do my rows now. My GCF here is x. My GCF here is positive 1. Remember, there is never a case where you don't have a GCF. If it's not something obvious, it's likely going to be a 1. Now I'm going to take these two parts, and that is my final and factored answer. Notice it matches what I started with at the very beginning of the problem. Factoring is multiplying in reverse. All right, so what if your numbers are a little bit bigger than what we just had? We can still use the X box method. So I have an X in my box, and I put A times C up here, so negative 24, and I put my B term here. Now I'm looking for factors of negative 24 that add up to negative 10. So what if I can't think of this off the top of my head? Well, down here on the side, I'm going to think of the different ways that I can make 24. I can do 12 times 2. I can do 8 times 3. I can also do 6 times 4. And that's all that comes to mind right now. So I'm going to go ahead and check what I've got and see if any of these combinations will get me to a negative 10. Well, right off the bat, I'm looking here and I say, oh, 6 times 4, 6 and 4, that adds to 10. But in order for it to multiply to a negative 24, it means one of my terms needs to be negative and one of my terms needs to be positive. So if I'm going to choose 6 and 4, one of them has to be negative. And let's say I make the 6 negative. Well, when I multiply them, I get negative 24. But when I add them, negative 6 plus 4, that gives me a negative 2. So there's no possible way to combine those to get to negative 10. 8 and 3, I can tell just by looking at it, there's no way to combine those to get to negative 10. But there might be a way to combine the 12 and the 2. If I make the 12 negative, negative 12 times 2 gives me negative 24. Negative 12 plus 2 gives me negative 10. So these are my numbers that I'm going to put in right here. And it doesn't matter if I have them switched. You'll still get the same answer at the very end of your problem. So now that I've figured out that my numbers are negative 12 and 2, I'm going to go ahead and put them into my box. So negative 12 and positive 2. Now I need to add in my variable. And what goes in this first box is the A. Notice I put the whole thing in there, okay, the whole thing. What goes in this box is the whole C, including the sign. Now I'm going to find the GCF of each row and each column. So I'm going to start here. I look for the GCF of my numbers, and it's a 1. I look for the GCF with my variables, and that's an X. I'm going to look for my GCF here, and that's going to be 4. But remember, I said that the sign in front of this number matches the sign right next to it. So since this is a negative 12, this is going to be a negative 4. Now I'm going to look at each row. 3x squared and negative 12x. My GCF is 3x, positive because that's the sign of the number right next to it. Here, my GCF is going to be a positive 2. So my final answer ends up being 3x plus 2 times x minus 4. And you can always check this by foiling it back out, by multiplying it, and you should get the original problem that you started with. You can always double check your factoring answers. All right, and one last kind of problem here. So how do you factor if you have 4 terms? Well, I'm first going to split it into 2 terms and 2 terms. Notice I took this subtraction sign right here, I changed it to a positive, and I put the negative with my 4x. This just makes it a little bit easier to keep track of that negative sign later. So I'm going to look at each binomial and I'm going to pull out the greatest common factor. So in looking right here, I can see that each of them have an x squared. So I'm going to factor out x squared, and what I have left is x minus 1. Now always take a second to multiply these back out again, distribute that x squared to make sure that it matches the original problem. X squared times x, that gives me x cubed. X squared times negative 1, that gives me negative x squared. So I know that what I have here is correct. Plus negative 4x and positive 4. I'm going to take out a greatest common factor of negative 4. And what I have left is x minus 1. If you're struggling with this GCF part, I suggest you take a look at the greatest common factor video that I also have on my website. I think you'll find it very helpful. So I'm going to take a second to multiply this back out. Negative 4 times x gives me negative 4x. Negative 4 times negative 1 gives me positive 4. It's so important that you take this 5 seconds to go back and multiply this back out in your head to make sure that each step matches the step in front of it. Next, I'm going to take out the greatest common factor once more, and each of these terms has a factor of x minus 1. And then I write what is left. If I take out x minus 1, I'm left with x squared minus 4. Now when you're factoring, you want to make sure that you factor all the way out. So this right here, some of you may have already noticed, it is difference of two squares. So I can factor that by taking the square root of each term. Square root of x squared is x. Square root of 4 is 2, and I make one of them a positive and one of them a negative. And then I simply bring down my x minus 1. Then this is my final factored answer for this problem.